Here are some examples of problems about solving compound and absolute value inequalities. Problem 1. Solve the inequality y minus 2 is greater than 1, or y plus 6 is less than 3, and graph the solution. First, we need to solve each of these separately. Y minus 2 greater than 1 can be solved by adding 2 to both sides of the equation. This gives us y is greater than 2 plus 1 equals 3, since the 2 and minus 2 on the left side will cancel. Now for the other equation, y plus 6 is less than 3. If we subtract 6 from both sides of this to isolate y, we'll have y is less than 3 minus 6, which is equal to minus 3. So our final equation is y is greater than 3, or y is less than minus 3. If we draw a number line like this, and have 0 here, 3 here, and minus 3 here, the region that y lies in is below minus 3, right there, and above 3. So that's the answer. Problem 2. Solve the inequality 2 times absolute value of x minus 2 plus 2 is greater than 2. First, let's write this out. 2 times absolute value x minus 2 plus 2 is greater than 2. Now we subtract 2 from both sides of the equation to get 2 times absolute value x minus 2 is greater than 0, since the minus 2 will cancel the 2 on both the left and right sides of this inequality. Now dividing both sides by 2, we find that absolute value of x minus 2 is greater than 0 over 2, which just equals 0. Now that we've isolated the absolute value, we can use the rule for splitting this into a compound inequality. This will give us x minus 2 is greater than 0, or x minus 2 is less than 0. If we add 2 to both of these halves, we get x is greater than 2, or x is less than 2. And that's our answer. However, notice we can state this more concisely as just x is not equal to 2. Problem 3. Solve the inequality absolute value of g plus 5 times 3 plus 1 is less than or equal to 9 minus absolute value of g plus 5. First, let's write this out. Absolute value of g plus 5 times 3 plus 1 is less than or equal to 9 minus absolute value of g plus 5. Notice how there's a term with absolute value of g plus 5 on both sides of this inequality. Let's combine them to make this much simpler. If we add absolute value of g plus 5 to both sides, we'll get absolute value of g plus 5 times 4, since 3 plus 1 is 4, plus 1 is less than or equal to 9. The other term with absolute value of g plus 5 will cancel the minus absolute value of g plus 5. Next, let's subtract 1 from both sides of this equation to get absolute value g plus 5 times 4 is less than or equal to 9 minus 1, which is equal to 8. Now let's divide both sides by 4. We get absolute value g plus 5 is less than or equal to 8 over 4, which equals 2. Finally, we can split this into two equations. Since we have absolute value of g plus 5 is less than or equal to 2, this becomes a compound inequality, which is minus 2 is less than or equal to g plus 5, which is less than or equal to 2. Now if we subtract minus 5 from both sides of both of these inequalities, we can actually just subtract minus 5 from each of these three expressions. This will give us minus 7 is less than or equal to g, which is less than or equal to 2 minus 5, which is minus 3. And that's the final answer.